Hello, this is episode 8 of New Uses for Old Circuits, Sound Design with Cybernetics. I first off wanted to thank all of you for the really great reception that this series has gotten so far. It's been a lot of work putting it together, but it's been really rewarding for me personally, and I've been really happy to see these ideas resonating with so many people. I have a lot of ideas for videos to come in the future, but I wanted to take this moment to pause and breathe for a bit because the past few videos have been quite heady, and I wanted to take the opportunity to synthesize everything we've talked about so far and present a video that's a little more focused on just creating sound. In the past few videos, we've looked at understanding what linear and nonlinear systems are. We've looked at feedback and how inserting nonlinear elements into a feedback loop create chaotic behavior. And then we dove really deep into one particular topic on chaos, the logistic map. And we use that as a frame for better understanding how to patch the synthesizer like an analog computer and begin to explore the really interesting meeting point between using an analog computer to model a physical system and using a synthesizer to create sound. And in the previous video, we looked back at the historical roots of cybernetics, namely Norbert Wiener's founding texts on the discipline, and went about creating a missile interception system on the synthesizer. In this video, I'd like to bring some of these threads together, creating feedback loops full of nonlinearities and then using cybernetic principles to regulate the feedback. And I figured what better way to do that than to revisit a patch that I explored in the first iteration of this channel from a few years ago. In the intervening years, I, as a musician, have continuously returned to this patch as a really rich source of sonic material. And so I want to present it again because I think this patch really embodies sort of the core concept of this channel, which is this balancing act between chaotic feedback systems and cybernetic regulation systems, and how bringing those two things together can open up really exciting new sonic worlds. With this patch, we take a noisy and chaotic galaxy of sound and use cybernetic principles to try to zoom in to see little bits of structure that can be found in the noisy, chaotic mass. If you couldn't already tell, I'm not really one for branding, but it seems to me that people will often come up with a patch and then try to brand it. And while I'm personally kind of allergic to that kind of thing, this is a patch that I had never really encountered anywhere before, and it's one that I have returned to constantly in my own music, so I figure I may as well put my own stamp on it. I've talked a bit so far about politics and authors that I like, and that's something that I plan on doing more and more as the channel goes forward. I hope it's becoming clear that I don't really see this channel as another sort of influencer channel, but rather just an artistic project of my own that I'm using to complement my work as an artist. To share some of the ideas that go into my own primary identity as an artist, which is my music, and provide a lot of what I hope is interesting supplemental information. Jorge Luis Borges, the Argentinian writer, sits next to Thomas Pynchon as perhaps the most important author that I've ever come across for me personally. He's inspired how I approach music making, how I approach art, how I approach life, how I see the world. His world of labyrinths, his gardens of forking paths are, I think, kind of exemplified by this patch that we're about to walk through. And so in a nod to Borges, I will name this patch after what else but a mathematics book from the 9th century. It was written by an Abbasid mathematician called al-Khwarizmi, and while its name in Arabic is quite long, it's often referred to us by the simple name of al-Jabr, from which naturally we get the word algebra. In the original Arabic title of this book, al-Jabr refers to the shuffling around of terms and the sort of canceling out of terms on different sides of an equation that you typically do when you're doing algebra. But there's another word in the title, al-Muqābala, which refers to the delicate balancing act that is another integral part of algebra. In this patch, we have a voltage try to explore the entire sonic map of a dense feedback loop, and we use cybernetic regulation to try and find inflection points and then stop and go back a little bit and kind of create this balancing act on the edge of these inflection points. So I don't know. In my head, I've been kind of referring to this as the al-Muqābala patch, but I don't know if that's going to stick. So the al-Muqābala patch is made up of a couple distinct elements, and I'm going to try to do something which I'm never very good at, which is color coding my patch cables so that everything is a little clearer. The heart of the patch is a feedback loop full of nonlinearities, and I'm going to patch those parts in yellow. Now, by far, some of the best sources of nonlinearity on the surge system are the middle and bottom sections of the wave multipliers. Normally, I would bridge them together with one of these shorting bars, and I usually kind of leave that there because, well, my system's always in this patch, but I'm going to use a patch cable instead to make it all clearer. So we'll create a feedback loop by taking the output of the bottom section of the wave multipliers and going in to the middle section. And then I'll take another patch cable and go from the output of the middle to the input of the bottom. So we have a feedback loop with two really intense nonlinear elements in it. Next, we want to hear this feedback loop, and I'm going to take the feedback loop and patch it to the output mixer, but I'm going to do that in blue so that we know that everything in blue is the audio path, but it's not part of the feedback loop. And I'm going to go from our feedback loop into the resonant EQ because the resonant equalizer makes everything sound really great. You can, of course, put the resonant equalizer in the feedback loop. In fact, you can really put anything in the feedback loop, but we're going to start with this kind of more simple one and put the resonant equalizer on top. I also personally find that I like the results a little better generally when the resonant EQ is kind of this, let's call it for lack of a better term, end of chain effect rather than when it's nestled in the loop. But when you put it within the loop, you get a really interesting, different set of sounds. So let's just listen to this basic feedback loop. So this basic feedback loop gives us a huge range of sound, and by adjusting the bias voltages of the wavefolder and rectifier respectively, we can navigate this vast sonic terrain. So the next thing I want to add is a voltage to move these parameters for me to sort of explore this terrain itself. And I'll use a cycling slope generator for that. So if I just take this slope generator output and say put it into one of these inputs, you can hear that we can use this voltage to drive through this map. Now the key idea behind this patch is to introduce a cybernetic element to monitor what's going on in the patch and regulate this motion of this driving voltage. And the most basic way we can do that is to use an envelope follower to monitor this patch and then invert the auto envelope follower to push back this voltage. The idea being that this voltage pushes us towards an inflection point, and then when we hit that inflection point, the envelope follower is activated and pulls this voltage back. So we can try and approach this sort of steady state balancing act in this chaotic mess of sound. The other thing about this patch is that that doesn't really work, but it does create this really, really dynamic control scheme, which basically makes the patch a lot more interesting. So I want to use white cables for the cybernetic elements of this patch. So what I'm going to do is monitor the output from the res EQ and go into a slope generator in a kind of envelope following configuration with the rise at minimum and adjusting the fall. So we're kind of monitoring the energy in the system. And then I'm going to take our driving voltage, put it into a voltage processor and have that at full strength, and then take our envelope follower and go into the same voltage processor and invert it to pull back on the red voltage whenever the system gets too full of energy. And then we'll patch the output to both inputs of our system here. You can hear the patch working right now as the red voltage drives towards the chaotic point, but then our envelope follower tries to pull back. Adjusting the fall time will give us very different responses. Playing with the resonant EQ bands and feedback amount really bring this patch to life. Another element I really like to add to this patch is to take our envelope follower and send it to a comparator. I'm sending it to a comparator on my system just to the right here, and use that comparator to trigger another slope generator whenever the envelope follower passes a certain threshold. You can see that other envelope generator here, and then when we add this other envelope generator to the CV processor, we get an even more reactive and dynamic system. And we can adjust which way this second envelope generator is moving things. One thing I like so much about this patch is it's actually pretty simple, and it was something I did in my very first surge panel. I had this wave multiplier res EQ, a dual slope generator with the CV processor, an SSG, and I used the SSG to set up a basic comparator just by loading a DC voltage into the sample input and running the envelope follower into the smooth input so that the coupler would compare the two. So I used that as a kind of basic comparator. And then the VCFQ and stereo mix. Like I said, that configuration was my very first surge system. And this patch was really inspired by taking all of these very basic classic surge circuits and trying to make them work in this weird cybernetic nonlinear system. And so you really don't need much other than the wave multipliers, a couple slope generators to get a lot of really fascinating, interesting motion. This patch is therefore a really, really great starting place. You can add elements to the nonlinear feedback loop, you can add elements to the cybernetic regulation system, or you can add elements to the audio path itself. I'm going to do that by, let's say, adding here, I'll move the camera to show that I'm going to add just to the audio coming out of the resonant EQ, I'm going to add a phaser and go into the spring reverb, and then come out of the spring reverb and go into another phaser and go into our mixer. And let's add our cybernetic regulator thing just to move the phasers. This isn't really doing anything cybernetic, but it'll probably sound pretty cool.